Two forces are given by F1 is negative 31.25, 18.75 newtons, and F2 is 7, negative 24 newtons. Determine the component of F1 that is acting parallel to F2. What we want here is the vector projection of F1 on F2. So that is F1 dot F2 divided by the modulus of F2 squared and then multiply by the vector F2. This part is going to produce a scalar, and so we need to multiply by F2 to have it in the direction F2. So that's going to be negative 31.25, 18.75 dot 7, negative 24 divided by, now this one is 724. The modulus of that, 7 squared plus 24 squared square rooted, is 25. So the modulus of F2 is 25, so that's going to be 25 squared. So what we need is negative 31.25 times 7, add 18.75 times negative 24, divide that by 25 squared, gives me negative 1.07. And of course, we've got the vector 7, negative 24 here. So that's going to be equal to negative 1.07, 7, negative 24. So negative 1.07 multiplied by 7 gives me negative 7.49. And then negative 1.07 multiplied by negative 24 is 25.68. We now want the component of F1 that is acting perpendicular to F2. Well, just as when you have a vector 4 this way and a vector 3 that way, that this final vector is just going to be equal to 4, 0 plus 0, 3, which is 4, 3. Because these are perpendicular vectors, we can do the same thing here if we're looking at perpendicular vectors. So what we would have, let's suppose that F is the vector we're after, then that added to the negative 7.49, 25.68, will give us F1, which is negative 31.25, 18.75. So our F is going to be negative 31.25, 18.75, take away negative 7.49, 25.68, and if we calculate that, it gives me negative 23.76 and negative 6.93 newtons. A small body acted on by 3 horizontal forces is in equilibrium on a smooth level table. One force has a magnitude of 75 newtons and acts on a bearing of 115 degrees. Determine the magnitudes of the other 2 forces given they act on bearings of 235 and 335. So let's say that this is our body. And what we'll do is we'll have north, south, west and east. So the first force we know about is of magnitude 75 newtons. And if it's on a bearing of 115 degrees, that means that this angle is 25 degrees because, of course, this is a right angle. Then we have a force here, which we'll say has magnitude P. It's on a bearing of 235. West is on a bearing of 270, so that tells us that this angle here is 35 degrees. And the final one is on a bearing of 335. Let's say the magnitude of that is Q. This angle here would be 65 degrees. So if we resolve our forces horizontally, then 75 cos 25 degrees acts east. That must be equal to the forces acting west, which is P cos 35 degrees and Q cos 65 degrees. Then if we look vertically, the Q is acting, or a component of Q is acting north. That would be Q sine 65 degrees. That's going to be equal to P sine 35, which is acting south, and also the 75 sine 25, which is acting south. We can just solve those using the simultaneous equation solver. So we've got 75 cos 25. Make sure I'm in degrees, is equal to, let's call P x cos 35 plus y cos 65. Oh, I missed the cos. So cos 65. Okay, and then we've got Q. Now that one is the y. So we've got y sine 65 is equal to x sine 35 and finally the 75 sine 25. And we just need to tell it that we're solving for x and y. And that gives me the x, which was the P, is 48.95 newtons, and the Q is 65.95 newtons.